Welcome back to CloudOps Lab. This is episode 4 of the DevOps Foundation series. In episode 3, we Dockerized an application. That gave us a repeatable package that can run on a laptop, in CI, or in the cloud. Now we are going to look at the next step, deployment to AWS. This episode is for beginners, so we will focus on the mental model. You do not need to memorize every AWS service today. What matters is understanding what happens between a Docker image and a running application. At a high level, deployment means taking a tested application artifact and running it in an environment where users can reach it. For a containerized app on AWS, the flow usually looks like this. First, your CI pipeline tests the code. Second, the pipeline builds a Docker image. Third, it tags the image with a version, often the commit SHA. Fourth, it pushes the image to a container registry. Fifth, AWS pulls that image and runs it on a compute platform. Sixth, traffic is routed to the running application. That is the big picture. Build an image, store it, run it, route traffic to it, and monitor it. On AWS, the container registry is usually Amazon Elastic Container Registry, often called ECR. Think of ECR as a private image storage location. Your pipeline pushes the image there. Your deployment service pulls the image from there. The next question is where the container runs. AWS gives you several options. You can run containers on ECS with Fargate, ECS on EC2, EKS with Kubernetes, or even App Runner for simpler use cases. For a beginner-friendly DevOps path, ECS Fargate is a good mental model. ECS means Elastic Container Service. Fargate means AWS manages the server infrastructure for you. You describe the container you want to run, and AWS handles the underlying machines. To understand ECS, remember 4 ideas. A cluster is the logical place where your service is run. A task definition is the blueprint for a container. It describes the image, CPU, memory, ports, environment variables, and logging. A task is a running copy of that blueprint. A service keeps the desired number of tasks running. If one task fails, the service starts another one. This is an important DevOps idea. You do not manually restart apps all day. You declare the desired state, and the platform works to keep that state true. Now let us place the load balancer into the picture. If users need to access the app from a browser, traffic usually enters through an application load balancer. The load balancer listens on a public address, receives HTTP or HTTPS traffic, and forwards requests to healthy running tasks. Health checks are important here. A deployment platform should not send traffic to a container just because it started. It should check that the app can actually respond. So a basic AWS container deployment has these pieces. ECR stores the image, ECS runs the container, Fargate manages the compute, a task definition describes the app, a service keeps the app running, a load balancer routes traffic, CloudWatch collects logs and metrics, IAM controls permissions. That sounds like a lot, but each part has a job. The pipeline does not need unlimited access to AWS. It only needs permission to push an image, update a service, and read the state required for deployment. This is where IAM becomes important. IAM is how AWS controls who or what can do an action. For production systems, you should avoid long-lived keys where possible. Modern setups often use identity federation, short-lived credentials, or deployment roles. For a beginner lab, the key principle is simple. Give the pipeline only the permissions it needs. Now let us talk about environment variables and secrets. Your Docker image should not contain passwords, API keys, or database credentials. The same image should be usable in development, staging, and production. The environment should provide configuration at runtime. That means values like API URLs, feature flags, and secrets should come from the deployment environment, not be baked into the image. On AWS, Those values can come from ECS environment variables, secrets manager, systems manager parameter store, or other platform configuration. Next, let us talk about deployment strategies. The simplest strategy is replacing old tasks with new tasks. ECS starts tasks using the new image and gradually stops the old ones. This is called a rolling deployment. The safer pattern is to make sure health checks pass before traffic moves fully to the new version. For more advanced systems, teams use blue-green deployments or canary deployments, but do not start there. Start with a simple rolling deployment that you understand. Here is the beginner checklist for deploying to AWS. Build the Docker image in CI. Tag the image with a clear version. Push the image to ECR. Create an ECS cluster. Create a task definition. Create a service on Fargate. Attach a load balancer if users need web access. Send logs to CloudWatch. Configure environment variables and secrets outside the image. Give the pipeline minimal IAM permissions. Update the ECS service from the pipeline. Verify health checks after deployment. If you can explain those steps, you understand the foundation of cloud deployment. The exact commands and screens will change over time. AWS services also have many settings, but the core DevOps flow stays the same. Build once, store the image, deploy the same image, route traffic only to healthy tasks, monitor what happens after release. That is the mindset you need. In the next episode, we will connect this to Kubernetes and learn the basic deployment concepts that power many modern platforms. If you want an AWS deployment checklist for ECS Fargate, subscribe to CloudOps Lab and comment AWS. DevOps is not about clicking every cloud button. It is about creating a reliable path from code to production.